So far, all of our revolutions have been around the x-axis, but it doesn't have to always be the x-axis. So in this example, let's look about what if we revolve around the y-axis. So if we revolve around the y-axis, let's take the region bounded by the square root of x, the x-axis, and the vertical line x equals 4. So this is our region. And we're going to revolve this around the y-axis. So I'm going to do a reflection of my region here. And then if I follow one point, I'm getting circles. And if I still want to do this with cross sections, well, this time instead of slicing vertically, I'm going to be slicing horizontally. So my cross section is actually going to be a washer. So we've learned how to handle washers, but the difference here is we've never sliced horizontally before. So kind of a way of thinking about this is the direction we stack the cross sections determines what we're going to be with respect to. So if I go back to the previous example here, our stacking was horizontal even though our slicing was vertical. But since we accumulated horizontally, we were with respect to x. Well, now we're going to be accumulating vertically. So stacking vertically, so we have to be with respect to y. So instead of saying y equals the square root of x, well, that means that y squared is equal to x. So in terms of my washer, the big circle, the radius, it doesn't change. My radius for the big circle is always going to be 4. But the radius for my small circle is where I hit the curve. Well, I'm going from the x-axis until I hit the curve horizontally, so that's x, which I said is y squared. And since I'm going to be accumulating vertically, I want this to be in terms of y. So the area of my washer is area of the big circle, pi times 4 squared, minus area of the small circle, pi times y squared, And then I want to accumulate my cross sections with respect to y. Well, that means my bounds are the y's. Well, my y's are going from 0 to 2. And so when I actually calculate this, I am getting 80.425.